There. All right, back in business. So, okay. All right, so I've heard that some people would like some C# review, which I'm more than happy for us to do that. So what I'm going to do is I think I'm going to push back the assignment due dates. So since the chapter 9 exercise 8 is has already been due, what I'll do for that one is you guys just try to turn it in you know, within by the time we finish going over the chapter 9 material. Okay, and so I guess I could just change the due date on that, but I'll change those due dates. Let me add that to my list of to-dos. Yeah. Change OOPII to due dates. All right. So, okay. I'm also going to post a new assignment to fill the time slot by moving up the other assignments. And that assignment is going to be some material that I use in Web Scripting 3, which is no longer a class, so I can recycle it in this class. There's some really nice resources here, so I'll be posting this link in the assignment so that you can take a look at this. There's some really nice videos to help get you up and running again with C#. All right. It says C# for absolute beginners. You guys aren't absolute beginners, but it's all the information that you might have forgot between semesters, especially with everything that's going on. You probably haven't been thinking about C# a lot over the summer, and I totally understand. All right. So, also, if you have experience with Python, this thing here will translate how to do things in Python in C# and vice versa. But I'll have you guys do these exercises for the assignment, and these will kind of help you get back in the swing of things. All right. So it says modify your Hello World program. So where is that? I think that must have been out here. You know what? I probably will just put the directions in the assignment too. All right, so. Oh, okay. The Hello World program. I think it literally is just this. Hello World, and you edit from there. So what does it say? Yeah, I'll put in the special directions so it's not as confusing. I'll modify this. Okay. Okay. So this says modify your Hello World program. You can just use the one from Replit when you create a new project. It's fine. Because I'm sure you guys know how to do this based on the submissions I've seen. But you can watch those videos if you need help. And I'm going to talk about a little bit, C#, a little bit of review. Checking. Right. I think I will check. Why is that up there? Okay, let's put that there. Okay. Fancy transition. Cool. Just want to make sure no one's emailing me if there's a problem. Oh man, 11 o'clock is when I get the most emails. Okay, let's see. Cool. Nope. Okay. Okay. So these are some very basic exercises to kind of remind you about data types. Mostly this is about data types, but it also has input and output, which you can't really do much without input output with just a console. So, and so for your assignments in this class, you can use Visual Studio or you can use Replit. Okay. I prefer Replit, but there are certain things that you can only do in Visual Studio. So when we get to the database section, you'll have to use Visual Studio. But just to make it easier to see what's going on, I'll try to use Replit as much as possible. And I set the assignment submission type as files in text box. So if you use Replit, you can submit the link in the text box. If you use Visual Studio, you can submit the file instead. And if you're crazy and you do both, you can submit both. All right. So let me copy this. It has some examples I want to show, but I just want to show you. So I create a new C# C# review. That'll confuse me a lot, that I have C# review and C# review demo. I just want to show you, here's what you start with in Replit. It's the Hello World program that you learn to do pretty much the first thing in every programming language. How do you do the output? Love you. All right. So from here, let's just talk about what we see. Using system, this line here tells this file that it also has access to the namespace system. So look through and find that. Someone else wrote that code. It's part of the basic input-output functionality and different things. So we don't have to program those. We can just use these pre-built parts, which is really nice. What part of system are we using? Well, if you take it out, it says the name console does not exist in the current context. So the current context means what this can see. This is what runs, and it can't see anything but what's in this file right now. Okay, so it says console. They don't know what console is. That's because it's in the system namespace. So we put that back, and then that should work. All right. I'm just going to comment this so it doesn't break everything. It's part of my next example. All right. So there's that. This specific class, main class, is used to it's basically a starting point. All right. And so here determines what can see this class. So if it's public, it can be seen from other files and things like that. Now, normally when we talk about classes and objects, we think of classes as a blueprint for creating objects. So an object is just an instance of a class. The class is kind of a set of directions to build an instance of an object. Okay, unless it has this kind of static function in here. What this means is there can only be one copy of this function. It's only run once. It doesn't. You can't create any kind of objects from this. It's just a class that gets called, and then it runs this code. It doesn't create objects, or the object it creates, there's only one of, because this is the code that the program starts with. So it makes sense that you would put it in a class that would limit the copies of this that would be made. If that's confusing, we'll go over that again later. What is void? That's the return type. So this will be the first thing that runs, and the last thing that runs is main class. So this is the return type. At the end of the program, it doesn't make any sense to return anything unless another program called this, but we're not doing that. So this is void because it doesn't return anything when this gets called. Okay, here's the name, main. Okay, because this is now let's go. I'll have to remember the naming conventions here, because this is a method, a static method of the main class. So, and what are these in the parentheses? These are the arguments. This whole thing here is called a function or method signature. Okay, so this is actually the name of the function, but this whole thing is the signature. All right, and then what's this? This is, and you can see in Replit, it probably does this in Visual Studio too. Links the curly braces together. This is a block of code. All right, inside of this block of code, we're calling the console object from system we learned. So we don't have to put system.console.writeLine. I think that would work. Yeah. It would be annoying if you had to add that every single time. Okay, so we put the using so we don't have to do that. Okay, I broke it. All right, get rid of this. Let's make sure it works. Always test your code after you get to a workable place. Okay, don't write the whole program and then test it. You're going to have a bad time. Okay, and I'm going to have a bad time because you'll send it to me and say, hey, I wrote all this code and it doesn't work. Will you fix it? Like, then I'll have to do that. Okay, anyway. C#, more information about C#. So it is a compiled language, which means when we hit run on Replit or you compile in Visual Studio, the code gets converted down into binary. So it gets converted down into multiple instructions. So this console.writeLine gets converted into binary, which tells the computer how to access the console, what characters to use to put it in the console. All that happens in here. We don't care about that because all we have to do is this, and it does all those million things for us. All right. So when we compile, when you use a compiled language and you compile it, it creates a file, and this is the file with the binary code. Okay, and you can see this text editor is having a problem reading this because it's full of zeros and ones, and it cannot interpret them as characters in the text editor. So it's like, I don't know what this is with a diamond, and I don't know what this is with a square. It kind of looks like it's freaking out. Okay, so we just ignore that for now. But that's what runs in the console when we hit run. Okay, so that I wanted to talk a little bit about this binary code. C# is an object-oriented language. It's a compiled language, but it's also a very high-level programming language. What does that mean? That means we can tell the computer to follow a multitude of steps very simply, so we can reduce the amount of code we have to write to do common things. All right, so I was going to show you an example of a lower level language down here. So this is called, this is an assembly language, and this is a low level language. In a high level language like C#, you don't even have to understand the hardware or the architecture of the computer to use it. If you do, you'll be much better at it, but I do want you to get this idea of this is a higher level language, okay? Assembly language is, I think only one step above just programming in binary, which you shouldn't do if you're sane. Anyway, this would be, okay, so this is an example in Python, because it's just simpler to show this. Python is a higher level language than assembly language by a lot. Lower level languages tend to communicate directly to the hardware in your computer. So we're talking about the memory or the RAM, the CPU, and the hard drive. Okay, so I put an example here. In Python, if you want to add two numbers and store it in a variable, you put one line like this. If you want to do that in assembly language, you have to know these commands, and I just remember these off the top of my head. They may not even be right, but this is short for move. It's for moving a value from a memory address in the RAM. So let's say this memory address contains 1. It moves that into the limited cache of the CPU. So the first spot for a value in the CPU, the value that's stored in this memory space is stored in the CPU, because we can't process anything outside of the CPU. So if we want to add two numbers together, first we have to put them into the CPU from memory. All right, and that is a very fast transaction of the computer. Okay, it's probably only, I'm going to assume a handful of instructions to the computer. And what am I talking about, instructions? Well, if you've ever heard, oh, this CPU has so many gigahertz, those are like billions of instructions a second. So if you have like 1 gigahertz, your computer can potentially process 1 billion instructions a second with that CPU, okay? Right now, that would be a very slow CPU, but still, it sounds powerful, right? It used to be. All right, you can look up what they used to go to the moon, and they were basically flying a tin can with a calculator in it. All right. So we'd move the first number to CPU 1, move the second number to CPU 2, and these could be somewhere, anywhere in memory. Maybe previously you would have created those in memory. And then inside the CPU, now that we have those two numbers, we can add them together. So we can do add the value in here and the value in here, and we put that in another spot in the CPU. And then, now that we have that value, we move it from CPU 3 to some new memory address in memory. Okay. All right. And that gets the values out of memory so they can be processed and back into memory. All right. So you can see as you get into lower level languages, you're telling it, you're specifying more specifics about what you're doing. So the whole point of that was C# is a high-level language, which is very good, so we don't have to program a binary or assembly language anymore, which is highly inefficient time-wise. It used to be good to have someone that knew this, or even in C++, you can access the memory and do things. I'm not sure if you can access the CPU. You might be able to. You might be able to use assembly in C++. It's been so long since I used that. The point, what was the point of that? Ooh, lost my train of thought there. Oh, so accessing or using assembly language that can directly access the hardware, that gives you total control of how things are processed. And so even though it's inefficient to write, you can go down into the hardware level and change how different things are done, what order they're done in, how it prioritizes things, to make things efficient on the memory to CPU, how things are being used. That is more of a operating system job, and it's a much higher level job. You may use this as a developer rarely, but one thing is in C#, since we've been programming for so long and developing these new languages, I believe C# does a good enough job of managing all your hardware interactions in an efficient manner that I doubt very many people could actually do it better than it just does automatically. All right, that's a lot to say about C#, but I just wanted to make sure that you knew a little bit more background information about C# in terms of other programming languages and where it came from. All right, so let's get to some more examples here. So let's say we want to make a new class. You can't see my head. Let's move into adding a new class. So it's a good idea to copy and paste. Let's call this class banana. All right. And when you create a class, you need to add a constructor method. So we use the name of the class in the signature. All right, and we set up some of the basic properties that we want to store in here. So, for example, if we wanted a string called name, let's give it the name of Bob the banana, and let's put an integer in there for age. No, that's weird. 30. Okay. Make sure it compiles. Whoops, I'm not even close to done there. All right. Oh, did I put double quotes around this? All right. Okay, hello world. And then let's come up here. And we have our new class. Let's create an object from that. So we do banana. Crap. No, I don't want to confuse you guys. Let's call it a plantain. All right. So the type is banana, because that's what the class is. We're going to give to the variable a name of plantain. So we've decided the data type is banana, variable name is plantain. Now we use the new keyword to reserve space for this object. So we make a new banana by calling the constructor. All right. And then let's call why did I call it plantain? That's not what it's called. Plantain. I spelled it wrong anyway. As long as you spell it right in both places. And I keep putting double quotes around everything. Okay. Banana is inaccessible. Oh, whoops. Gotta make this public. Did I do that on purpose to bring up the method signatures, or did I make that mistake on purpose or on accident? You decide. Okay, but it says banana is inaccessible due to its protection level. This here is its protection level, and I believe I have to look this up. If you don't specify the protection level, it defaults to private. I'm not 100% sure on that, but just make your constructors public, because you're never going to make an object if you don't. Okay, so I printed out just plantain, all right, which is what? It's a banana with the name Bob and the age of 30. So all it printed out was what the object type is, banana, all right? Not very useful right now, but could be for debugging later. Let's do one of the properties, so we can do .name. Do I need to make these public too? Oh, derp. I gotta set them as properties up here. I don't want to declare them here. Alright. So string public string name. Right, and then we can do public int age. All right, let's see if that works. Okay, so got to declare your properties before your methods. Properties are just a fancy name for variables inside of a class or object. And methods are just a fancy name for functions within a class or object. All right. Excuse me. Nobody make a compilation video of my mistakes and burping, please. So there's the basic way to create a new class, set up the properties, a constructor method, access the properties, or create an instance of that class called an object. All right. And then we console.writeLine one of the properties. We use the variable, and we want to grab the name from that. So since we made these public, we don't have any get or set methods yet. So since we set them to public, I think we can directly access and manipulate the properties. Whoopsies. Dang it. What am I pressing? Okay, undo, redo. Okay. We're good. So this wraparound is making it harder for me, so let's fix this. There we go. So let's do this. Let's create another one. And let's create another constructor here. So let's say we want to determine the banana's name and age ourselves. So you can have multiple methods with the same name, okay? But they have to have different method signatures, okay? So I can have banana. This represents create a banana object with these default values if you don't enter any arguments. But we can enter in some arguments. These are actually, on this point in the method, when we're writing the signature definition for a method, these aren't called arguments, these are called parameters. So do name and int age. So in the signature, I'm saying if you create a banana by using this constructor method, which means you put banana and then in parentheses, you put a string and you put an integer, those will be variables that you can access within this method. So let's follow through. Okay, so don't be confused by the property names versus the parameter names. Okay, they're two different things, but it makes it a lot easier if you do it this way, where you make the parameters lowercase and you keep the properties uppercase, so that way you know that they are properties and not just some random variable like this. Okay, so how does that look when we use it? So we're creating one banana using the default settings. We're going to create another banana called Dole. Wait, no, Chiquita. I wonder if they had to change their logo. Nope. Chiquita. I thought that's how you spelled it. All right. You know, I don't even like bananas all that much. I always tell people, you know, have you ever eaten a banana and said, that was good, I want another banana? Anyway. Okay, so here we're going to create a new banana, but we get to choose the name. So let's do Sally, and the age will be 25. All right. Chiquita. So we should see Bob and Sally in there. I'm going to make the output a little easier to read by doing this. This is string concatenation. Whoops, I want to put that in here. Like so. And then plus. All right. Do the same for this one. because I want to show you something that I hope you understand, but if you don't, it might blow your mind and break you. Whoops, this is Chiquita. So that way you can see the plantain.name property is Bob, the Chiquita.name property is Sally. Let's create another one here. We'll separate it just so you can see that this is different. And we want to make it banana names. Well, blue Java banana. We'll just call it blue Java. And then if you're making a variable with 2 words, remember? You know what? I've heard different things on the C# variable naming conventions, because, you know, the book is from 2017, I believe, and these things change all the time. All right, so if you're ever confused, here's the thing. This semester, I'm teaching JavaScript, Python, C#, HTML, CSS, even though those are kind of easy. Yeah, is it just that? SQL, 6 languages that I got to keep straight. So unless you use these every day in your job, it's fine to have to look this stuff up. I'm trying to show you that I don't know everything off the top of my head anyway. Once you know the general idea, you can find it. Okay, first character of all words are uppercase and other characters are lowercase. Camel casing is that. Okay, so it says for C#, we want to use Pascal for class names. Okay, we want to be able to identify classes. Method names, I guess we're going to use all caps. Okay. Camel casing for variables and method parameters. Perfect. Okay, just wanted to make sure. Does this have a date on it? This website does not look up to date. Okay, I didn't even notice that. Okay, let's see if we can. Here's one from Microsoft. I think we can trust this a bit more than that other site. So remember, these naming conventions are just for readers of the code. The computer doesn't care. You can actually get an add-on in Visual Studio Code. There might even be one in Replit. You can do database in here. I did not know that. Cool. So maybe we don't have to use it if we don't need to. Ooh. Anyway, what are those naming conventions? Okay. C#. Actually, we don't want, yeah, we do want naming. Well, here they've got a variable and they're using camel casing. Here's an object and a method. So they're using, or these are called. Let's see if there's more about this. Here we go. I think I just want to know naming objects in C. C#. This is the kind of stuff that's important to do right in the beginning because it's much harder to unlearn bad habits than it is to just do them in the beginning. So when I look at your code, at this point, I'm going to be very picky about naming conventions and indenting. And I think on Replit with the indenting, there is no, it looks like they don't do it on C#, which is unfortunate. There used to be a auto formatter. There's probably a website that auto formats C# that you can use if you mess up your spacing or you forget something. You can just go, let's see, C# spacing. Oh, code spacing. Here we go. Let's see. So in Visual Studio, it looks like you guys will have to tell me if it automatically does that. I haven't used Visual Studio in a long time. I'm not going to calculate it. All right. It's less than a decade. Yeah, it's been less than a decade, so. Yeah. All right, so you guys tell me, but. Oh, okay. Anyway, you might have to manually do it if you do replit, but. So this variable name can be camel case. All that for that. Okay. And we're actually just going to create the variable. So what we're doing is we're declaring a variable of blue Java with the type of banana. Okay. So if we try to console.write just that empty variable, let's see what happens. You should always be messing around with stuff and seeing how things work. You got to have curiosity. Okay. It also takes a little bit longer to run C# because it's a compiled code. There's 2 steps. Compile, then run. So it might take a little bit longer to do that. We'll come back. Okay. Use of unassigned local variable. Okay, so that won't work. So we need to give it a value before we can print it out. So let's just, to save time, let's just copy the value from one of the other bananas. So we'll give blue Java, put Chiquita in blue Java. Make sure this isn't one of you contacting me. All right. Let's see if that does anything different. See if that fixes the problem. All right, so blue Java is a object of banana type. Okay, based on the time it's taking to process this, I might write more code before I test it, so we don't have to wait as long in between uses. So if we take a look at the name of blue Java, and let's take a look at its age. And I said I wasn't going to do this. I wonder if it'll let me edit the code while it's running that original code. All right. It's going to spit out, we know, it's going to spit out the same stuff from Chiquita, which is Sally 25. Okay. Let's put some stuff in here, because we're going to put a lot and it's going to be hard to keep track of. Also, you guys are learning so much about bananas, aren't you? Would you eat a blue banana? Sounds like Dr. Seuss. Blue bananas and ham. All right. Okay, so Sure, that'll work. I would normally run it, but I'm trying to save time here. So we know that'll show Sally and 25 again. All right, let's change Blue Java's information to its own information. So change this property to, what's a blue name? Okay. I'll just call it coffee because it's Java. I wonder if the banana tastes like coffee. That'd be gross. And let's change the age. Blue Java's old. All right. And then we'll print those out again to see if that worked. And to make this a little bit easier to see, I'm just going to put in some escape characters, \n, to space this out. So we'll put a line there, and put one there so that we know, whoops, that those are kind of different categories. An extra line between them. All right, so let's take a look at that, make sure it can change the properties correctly. Did I type it wrong? Okay, line 17, character 39. Oh, derp, forgot the plus sign. You guys are probably all screaming at the screen. All right. Next is line 23. The more you use C#, the less you'll have to trial and error things like this, but that's where you're starting out somewhere. All right, line 23. Also forgot my plus sign there. Hopefully I'm not too frustrating to watch. It's good to see the process too, because you need to adopt this kind of process, especially when I start introducing ideas for debugging. Okay, so we have we used Chiquita's information, so it's Sally 25, and then we changed it to coffee 65. Right. So let's put the ending information for all three bananas at the end. So we'll also put final bananas. /n, put a bunch of underscores, and maybe less underscores. Okay. Ooh, one more and I can go on the same line. Awesome. Anyone make it in? Okay. Grace mentioned, will you show how to use the Compareto method? Yes, that is a very good question. Okay. Let me just finish this up. I'm very close to done with this one specific part, and then we'll go to that because I kind of didn't know what you guys wanted to see here in the beginning, so I'm just starting from scratch. So Grace, tell me how much of this is like that you remember from OOPI. Okay, I'm just curious what I should expect, because I know you're on top of things. So if you know this stuff, then I know everyone else should. All right, that's ready for this class. I'll use you as my bar, since you're the only one here. Thanks for showing up, by the way. Okay. Anyway, so we're printing this out. We want to print out all 3 bananas stats. And so I don't want this line between, well, let's put the line between everyone. Except don't need final bananas. And we'll take that, so there. Try to make it look kind of good. Oh, I forgot to change the names. Okay, so the first one is Blue Java. This one is going to be Plantain. Oh, this is a nice thing. I'm not sure if you can do this in Visual Studio, but I can put this here, hold Control, and then click here and here. All right, then I can get rid of all of this and change it to Plantain, and I'll have to type it once for all those spots. Okay, so down here I want to put in Chiquita, so I'll select Blue Java here. I'll hold Control, select it here, hold Control. I wonder if I can double click Control, double click here. Yeah, that's even faster. Okay, and then I can put in Chiquita. All right, so you can see if you know how to use your development environment or your text editor, you can do things a lot more efficiently. All right, so we should see for the final bananas, we should see Blue Java, right? We changed that to Coffee 65. Plantain is Bob and 30. And Chiquita should be Sally 25, right? Why is it Coffee and 65? We didn't change Chiquita. We only changed Blue Java. So why did it change both? Okay. Why did it change both? This is a very important thing to understand in object-oriented programming. Okay. Remember when we created an object here? This right here creates the object. And the new keyword tells your system to reserve enough space in the memory to store this banana object with its properties. All right? And that spot in memory has an address. So there's a lot of spots in memory, and they have hexadecimal addresses. It's almost like, you go down the block, everyone, has a different number. House number 1, 2, 3, 4, and they have different people in each one. So this is the same thing. It actually just tells it where the spot in memory is open to fit this. Okay, and so I created an object, and what I'm storing in the variable is not the object. Okay, this is difficult to understand in the beginning. I'm not storing the object in Plantain. A more accurate way to describe it is I'm storing the memory address of where banana starts in Plantain. So why does that matter? Okay, so we stored, this is Bob the banana default, right? So that Bob banana gets created in memory, and then the address to that is stored in Plantain, because we created a new object, create another one here. This tells it to find a space in memory to fit it, all right, and then we store where it starts in memory here. Okay, so the problem, or maybe we wanted it this way, because you can use this both ways, but you have to understand what is happening. So what is happening on line 10? Remember, what is plantain and Chiquita? If it wasn't copyrighted, I would play the Jeopardy music now, but I don't want to get the audio removed from my video on YouTube. All right, hopefully you've had enough time to think about it. So if plantain is the memory address of this object, and Chiquita is the memory address of this object, when we assign the value from Chiquita into Blue Java, we're just putting the reference of where Chiquita is in Blue Java. So Blue Java and Chiquita from now on are pointing at the same object in memory. If I make a change to one, it's going to change the other. Okay? There are times when you want this, and there are times when you don't. So you need to understand how you can manipulate objects, and using objects in a variable is actually just the reference in memory. Now, why does it do that? So think about the data types, a string, an integer. I'll just use those as examples. All right, they do not take up very much space at all. Now, an object can have a lot of properties, so it could potentially take up a lot of space. All right. If we want to be able to reference an object that's really large, we don't want to have to keep making copies of it in memory, because you'll crash the computer. All right. And this won't be very good software. So if we want to use that object and give it a different name, it doesn't create a new copy of the object. This doesn't create a copy of Chiquita in Blue Java. It doesn't create a copy of the object. It just creates a reference. You can think of it as a pointer. Okay? So I live at my house, but I'm not this. This is just my address, okay, to my house. And once you get there, then you can see me. And my name's not Sally. Okay. And I'm definitely not 25. Okay. I wish. I want my brain now when I was 25. No, when I was 18. But I wouldn't have had as much experience, so that would be impossible. Anyway, listen to older people. Their wisdom can help you a lot. Okay. So Compareto now. Sorry, Grace. You had to wait so long. Let's go ahead and talk about that. And now in my mind, I'm remembering, because I mentioned it, it's a pretty big deal. So whenever you have a question about anything in C#, you should, well, you guys know, you probably go to Stack Overflow all the time. But there's also the documentation. Okay. And I was looking ahead, and I think you probably were talking about this comparable, because I think one of the exercises wanted you to do this. Wait, was it the first one? Let's take a look. I should have opened the textbook anyway. But I guess I wasn't going to talk about the exercises. But since you're here, Grace, and you're asking the question, I'm more than happy to demonstrate. And maybe someone else in the class needs this information too. If you don't, you can skip over this part of the video. All right. So publishers only give me the digital versions of the book now. I should consider myself lucky they give me that. It's such a nice day out today. Gotta wear a jacket though. Oh, good, it saved where I was. Okay. Yeah. So are you talking about this, Grace? Include properties for each field. Also include an iComparable.compareTo method so that conference objects can be sorted. All right, so let's take a look at that. So I'm looking at the Microsoft C# documentation for iComparable.compareTo method. All right. So it says compares the current instance with another object of the same type and returns an integer that indicates whether the current instance proceeds, follows, or occurs in the same position in the sort order as the other object. So if I gave you a stack of books and told you to alphabetize them by name, and one of them started with A and one of them started with B, you know the right order for those is A, B. If I gave you 10 numbers and I told you to put them in order, you know you go from smallest value to largest. So in the exercise, it says, include a da-da-da method so that conference objects can be sorted. Okay, so a conference object. Let's say I gave you 2 conference objects. How would you sort those? Well, however you decide, by adding a compare-to method, you're telling the computer how you want it to sort them. Okay, so I hope I'm on the right. I think that's right. It says conferences. Yes, okay. Okay. Okay, looks like I am looking at the right thing. Cool, cool. All right, so we can go back to our banana thing. All right. Ugh, do I need to create a list for this? Just gotta look at the syntax again real quick. I think this has it in here. Data types, flow control, collections. That's what we want. There we go. Lists and arrays. So let's create a list of bananas. Then we'll sort it using a compare-to method that we create, and then we'll print them out in order. Okay, so they also have it in Python here if you care about that. So we'll need to use collections for that, system.collections, to have access to lists. So throw that in under system so we don't have to type collections.generic.list every time we want to use it. All right. Next step. All right. We want to create a list of bananas, in this case, conferences in your case. So I'm going to keep this code in here. I'm just going to block comment it out. So when I send this to you, you guys can turn it on or off depending on what you want to do. So let's get rid of this. Boop, turn that off. And I'll just put a little label here. It says, what did I do in here? Objects. Classes and objects. Basics. Okay. And then under that, we'll put, no, above it. Let's put it above it so we don't have to keep scrolling. I think we will have to scroll. Do I have a minus in there? I do, but not for comments. Darn it. Dang it. Okay. Let's just put it up here. All right. So we need that list. So we're going to be creating a list of banana type. So it's a list of only bananas. We'll call it, whoops. Will you tell me, Grace, if you're still there, can you hear that music in the background? Because I forgot to turn it off, and I really don't want this video to get taken down. I don't have to do this again. So I hope you got, this doesn't turn on your smart home device, but Alexa, stop. I know it's the algorithm that looks at this, but if a human is reviewing this video, please don't take the audio out. Please. Good. Thank you, Grace. It must have been quiet enough. That's not picking it up. I just had some relaxation music on while I read emails and grade. Anyway, okay. So this creates a variable that can hold a list of banana objects, remember? Or that can hold a reference to a list of banana objects. I'm going to keep harping on that. So we use the constructor for a list of banana type. Let's make sure that doesn't break everything. Okay, cool. And now we can add things to that. So let's create our bananas up here. So we can reuse these for sure. Awesome, awesome. This one we'll have to redo. Java. So we actually got rid of the Java class at Lakeland because if you learn C#, it's just a more strict version of Java. And so everything you do in here is very closely backwards compatible with Java. So learning Java, if you learn C#, is kind of a waste of your money. So if you're going to end up using Java, you might want to familiarize yourself with it. But this practicing C# is going to make it so much simpler. Okay, there are a lot of companies that still use Java, so you theoretically could get a job programming with any of the languages that I teach. If you knew Logan Malcolm, one of my previous students, got a programming job. He does Python, race. I hope Race doesn't see this. I always forget his last name. Underwood, Race Underwood, also got a job programming in Python and JavaScript. So they do use C# in, I think at Patterson, Heartland, and there's a company called Smart Software Solutions that's owned by JJ Ventures, and that's the company that owns like the gaming machines or something. Anyway, very wealthy company after they changed the gambling laws in Illinois. All right. Anyway, I could go on and on about how those places are basically, you can make a cartoon of sheep walking in with their wool and then the sheep walking out after they've been sheared. That's what those places are to me. Anyway, some people call it the idiot tax too, but that's not very nice. If people are going to gamble all their money away. They need help. They don't need more gambling or more, someone to put them down. Anyway, did I buy enough time for myself? No, I just went on a rant. I just rambled. Chiquita. All right. Okay, so we called this guy Coffee. And it was 65. Okay, let's make sure that all works. All right, no errors. We're not seeing anything because there isn't anything being output. So how do we get those bananas into the list? I don't think we want to call the list banana. We want to call the list of bananas banana list, right? Okay. Lots of bananas. And then to populate it, we can just do banana list. And so when it comes up in Replit, you just hit tab. And then there's a method in there called let's see, I should have access to this. Dot elections dot. Oh, I think I have autocomplete off. That's why. No, it's enabled. Because it's only showing me my the stuff I have here. So it's only showing me my variable names and stuff, which is nice for saving time. Because you don't want to use all your variable names as X and Y and blah, blah, blah. You want to give them meaningful names. The size of the name of the variable only affects your ability to read and interpret the code. So if you use too long of a name, that looks like a nightmare. If you use too short of a name, no one knows what you're doing. So you got to strike a balance. Okay, I want to look at lists in here just for the syntax. So just look up another one here. So let's go C# list. Also, this right here, after list, it has a special name. Let's see if I can remember it. So here they're creating something very confusing. I don't want to talk about that right now. Okay, here we go. Create a list. Here it is. It's the list.add function is what we want. And then looks like they're using this kind of shorthand to set the properties. Okay. It would all go on the same line anyway. I wonder if doing it this way. I think they did it this way. Let's see if we can find part. Is that in here? The part class. Oh, okay. Part. Where's the? Oh, okay. So they're using properties of get and set. So that's why they can do this. Okay. We'll do it manually, but later on, if you want to do it this way too, you can. Using this is way more closer to what you would do in the job. So knowing how to use the get sets is good. For this example, I'll keep doing it the hard-coded way, and then I just don't want to have to go back and re-edit everything. Okay, so we want to do add. Oh, now it wants to show up. Oh, no, we don't want it there. We want it here. second. It's a method, though. Let's go for lowercase. Okay. Oh. Parts. No, it's just a variable here. And it's just a list. Okay, so I should have access to all the list methods, including add. So let's do that. Let's use capital. And it's set that up right. Okay, and we're going to add a new. Oh, no, we're not going to add a new banana. We already created. Okay, ours already have the property set. That's what was confusing me. Okay, plantain. Oops, I want this. No. Do I want this? Oh, I forgot. I'm trying to use keyboard shortcuts, but it's failing on me. Chiquita. I wonder if you could do this all in one. Probably not. But it actually might have a constructor that can take multiple values. I'm actually curious about that. And this may be a waste of time. I'm always learning new stuff every time I do one of these classes. And you're never going to stop learning stuff about this. There's just too much. In a job, you don't have to know everything. You just specialize in the things that you need for your job. Okay, location of the symbol related to previous error. So line 11. So I don't think I like that. No overload for method add. Okay, so that means it can only do one argument. So if we just undo all that. Now run it. Oh, we won't see anything still. Oh, but we can check for errors. Cool. Worked. All right. So now we want to do a loop. And one thing that's really nice in C# is this for each loop. You can do this in Java, but it's a little more complicated. I'm trying to think of where else you can do it. I know Python and JavaScript have it, but they're loosely typed. So this is just so nice and quick for throwing in a loop on a collection. So tell me if you guys have seen for each or not. Hopefully, it's so good. Here's the code. Okay. If you have this on full screen and I keep switching between white and black, try not to blow your eyes out, but sorry. Okay, so if we do a for each loop, for each banana, so we're deciding the data type for the objects that we're going to pull out of the list by setting this here. And now we're just choosing an identifier to reference each item in the list as it goes through the loop. So when it says for each, that means it's going to look for each object in the list. So to just include everything. So you don't have to know how many there are. You don't have to remember, if I use a greater than or equal sign on my loop, if this adjusts, you don't have to, if you add more or take things away, you don't have to adjust the numbers. Just very efficient way to do loops. Okay. So our list was banana list, and I'll just keep this as a part, I guess. I can't think of something to name it in here. It doesn't matter. You're not going to see this anywhere. It just has to be different so it knows that's referring to that. Okay. So it is telling us there's 3 objects. Let's get their names. I promise we'll get to the compare to here. Okay, and then pages too. And let's do little divider here. Actually, I could just do it in this one. You could do this all in one. Like this. Just depends on how you want to do it. Put a line there. We'll put a line here. Okay. And then before that line, we'll put these. Let's see what that looks like. So those are the three things in the list. So we created a list. Well, we made sure we put in collections generic so that we can refer to lists easier. We created one. Created a variable to hold the reference to the object. Created space in memory to store the object. Also, if you remember the order of operations, this may help. If you remember the order of operations, assignment is, if not the last, it is towards the end of the order of operations, is assignment, which means this will evaluate first and create the object, and then that returns the location in memory where it gets stored back, and that's what gets stored here. So once this is done evaluating, then it will evaluate this and assign the reference to here. Okay? Next is, let's see if we can get that compare to. So let's say we want to sort the bananas by name alphabetically. Okay? Well, we're not sorting the names in the list. We have to sort the banana objects, which include two properties. So it's not going to natively know how to sort bananas. So we have to tell it. Okay, so we have to tell it what order we want this in based on, you know, how we want to do it. Do we want to do it in reverse alphabetical order? Do we want to do an alphabetical order? Do we want to do it in numerical or reverse numerical order on the age? Do we want to do it on like the ASCII value of the character, the sum of the ASCII values of the characters added to the age? You can do whatever you want to sort it. The idea is to do it in a way that is useful information. So, okay, let's try reverse numerical. So we're going to say, you know, this is a list for the line to get into Disneyland. Well, Blue Java doesn't have as much time as the other two, so they're going to let him go first. Well, there's our problem case, okay? And we need to create a solution to help figure out the order people should be let into Disneyland, all right? Did I say people? I mean bananas, anthropomorphic bananas. What order? And we want that order to be based on their age. All right, so. All right, so here, following example illustrates the use of compare to compare a temperature object with another object. All right. That is. All right, so see where they wrote the code. Here we go. Temperature F which is what? Is that a variable somewhere? It's a double here. Okay, so it's not a list, it's a double in this case. So it's only going to compare it. Since it's a double, I believe it'll just put it in numerical order. Okay, let's see one that's using a list. Here we go. So here's a list. Here they're using an array list. Okay, and then I forget off the top of my head, array list versus list. List and array list is that list is an interface. Okay, I don't know if you guys talked about interfaces yet. While array list is a class. All right. So an array list actually implements the list interface, which means that array list is a subtype of list. Okay, an interface is code that kind of connects the ability to use classes together and communicate together, even if they're different types. It's used in very high-level programming, like if you're developing the back end for some web app and you have to mess with this network parts of it and keep track of a bunch of stuff. You might keep track of the connection and keep track of different things. You might need to use an interface. Anyway, let's not talk about it now. So array list has all the functionality of list. So we're just going to stay with list for now. Unless we can find a reason not to. Let's take a little more research. I'm sure someone has an opinion on that. All right, so we have this list created, and then we're printing it out, but now we need to sort it. Oh yeah, so I was looking for the actual compare to for a list. Calling it. Generate 10 temperatures and sort it. Oh, so they're just using the sort method. Okay. Because I think the list is, again, just, it's not objects. It is degree temperatures, and they insert degrees. So it's an integer that gets added. So they can use the sort. It knows how to sort integers. All right, da-da-da-da. I'm just trying to see the way you can create your own compare to. It should be in here. Let's try looking this up. I don't think it's called overloading. We need to extend, I think. Extend compare to, I think that's what it's called. Yeah. Extending the comparable interface and override the normal compare to. All right, see, I know this has been asked 1,000 times. Okay. See, the thing is, they show you the question first, and then so you look at the code. Just realize that usually the people asking the question are showing code that doesn't work, so you just skip that. First, you should interpret whether it's the right question to ask, and then you can look at the answers. Okay, and so some comments. The more you learn the terminology, the more you will be able to interpret. Okay, so we need to create this. Implement. Do they really want you to do all this? Where's the book? What is chapter 9? Using classes and objects. Let's look in there. Let's see for a second here. Arrays. Oh, you know what? This is a digital book. We can just search. Probably going to want the later one. There we go, 397. It's on the next page. Yeah. Okay. It looks like you're figuring it out, Grace, which is good. I hope this is helping. Please let me know if this is helping. We'll be doing this every week, but if we need a little bit extra, I might throw some extra ones in. Again, these are optional. If you show up, you can ask questions, and I'll focus on your questions, so you get a little bonus. If you don't show up, you can just rewatch the video. I'll post it. I'll make a playlist, and then you can catch up on that. Okay, so where was I here? Oh, the textbook, right? Okay. So we need to override. That's what it is, not extend. Okay, we need to overwrite the normal compare to method. All right. You must include a single colon and the interface name after the class name. So you must write a method that contains the following header. I guess they're also calling them headers for different things. Okay, maybe they have an example soon of the syntax. Okay, so yeah, this is what we need right here on page 398. So we need to make the conference I comparable. Okay, so we'll copy this code, or I guess you'll type it, unless you can find a digital version of the book, which probably isn't that hard if you know what you're doing. Not that I'm condoning that. I would never condone that. I guess your books are paid for by you, I guess, for the rental fee, but you don't actually have to buy the book as long as you return it in time at the end of the semester. I hope they're more lenient and they don't do the book return in 2 days, because those lines are going to be terrible. I should talk to the bookstore about that. Okay. Ask about book return. And hopefully they give you guys more time to do that, so you don't have to go in a large crowd. That would be so stupid. All right. And just imagine that happening too. All right, where were we? Oh yeah, we're creating a, we got to go down to our banana class here and make it. Also, I think in the book, one thing I noticed is the book is a dropper, of curly braces, and I like to save lines and put mine on the same line, but it probably is easier to see the start and end if they're on the same line, but then your code gets way more bloated. So with these extra lines, I'm not so crazy that I put my closing one on the last line. Now that's insane. I'm just kidding. If you talk to different programmers, they're going to argue about this, and they'll argue about spacing, which is funny. Spacing or indenting your code with tabs versus double spaces. You don't have to worry about that replit because a tab, it just converts a tab into double spaces. Also, that saves a lot more space if you double space indent. You save space horizontally. Okay. It wanted me to take my banana and call it iComparable. So we're using an interface. You know that because they're always named with an I in the beginning. And what this allows us to do, okay, sorry. Dang it. Capital C. Okay. Comparable. So it's saying this banana class can use the iComparable interface, which gives it access to every other, or iComparable is going to have method signatures in it with no code. In the methods. But what that allows you to do is overwrite those methods in your code. So now I've made banana and iComparable. I can include a new method called public, and I want to be able to call this from the object, I believe, not the class. Comparable int iComparable dot compare to object O. Instance method. That is, it belongs to an employee. Okay, yeah, it's an instance method because it does not have, in the method's signature, it does not have static, okay? If it has static, then you can call the method from the class, kind of like console.writeLine. Console.writeLine, writeLine is a static method of the console. We don't have to create a new console object and do writeLine. We just use the class. And so if you ever see calling a class with a method, you know that's a static method. If it's the object name with a method, then you know it's an instance method. Okay, I want to finish this comparable thing, and then I'll let you guys work on those things. Okay, let's see what's Grace saying. Oh, did I pull this out of the, I must have pulled this out. Okay. Have you been able to see this at all during the recording, Grace? I hope so. Okay. And I'll just continue. Now you can see it. You'll have access to this, so you can just look at it and listen to the video if you couldn't see it. Sorry. Yeah, who knows how long ago that you said that. I'm sorry. So anyway, now we can add our own compare-to method. That's what we need to do now. Which in the textbook is this right here. So they're giving it a return type event. And then inside of here are the directions to sort employees. But we need to put the rules for sorting bananas. All right, come on, textbook. Why are you doing this to me? Okay. Oh, this is shaded. It's not selected. Sorry. Okay, now copy this. Maybe it is easier to type it than to get it out of here. Okay. So we've got our properties, constructors, and now we're putting other methods. This one happens to be okay. So out of the book, it put it all on the same line. Oh boy. Da-da-da. I don't need. Did I copy the right? Oh, did I? It didn't copy it all. Oh, I just need the signature. Okay. Does not like to copy those early braces. So I'll have to put those in manually. Jeez. Here's where the method opens. And then Replic's trying to help me, but I need this to go down here. Okay. And then I wish there was a code sort type thing in here, but I'm going to have to manually do it, so it's easy. It's not too bad. Just I'll do this after each semicolon. We can close this to make it easier to see. Okay. So this says it will return the return value as either the variable, oops, or either as the value that's calculated, or it uses the, it just gives you a 0. So this might be just a safety, but anyway, you'll pass in. You actually won't be passing in an object. The list, when it compares the objects, will use this method that you added. All right, so we are declaring a variable. Employee temp equals employee. Okay. So here, the parameter says object O, which means when we pass in an object to this, well, when it passes in an object to this, it'll call it O. All right. That means it's an object at that point. It's no longer a banana, it's just an object. So all objects you make have a parent class of object. I believe it's the highest level is an object, and all other objects and classes you make extend off of that. So it has all the basic features of an object, like, well, you can look it up. Anyway, just look up the object class in C#, and it shows you basic functions you have, methods. So we can leave this as O. So here, what are they doing? They're declaring a new employee object reference into this variable, and they're just putting the object that was passed in as argument, but we can't put an object in this employee thing. We don't want it as an object. We want it as an employee. So since we know the object in this case is banana, and it's only ever going to be banana, we need to make that object back into a banana. So we cast it back into a banana, and what this does is it says, okay, we're going to go off of the object reference that you gave us, but instead of just going as far as looking for an object, we also know you need the information as if it was a banana. Okay, so that allows us to take in an object, convert it to banana type, and then store that in temp. That way we can manipulate or calculate out what we think the order is. Okay, so the way you do that is use this if, else. And one thing you may notice is because these are the if statements only, the if, else if, and else only have one line on them, you can just do this all in one line. Again, you guys can do it as long as it's a correct way. Sometimes people like to put the curly braces here just in case they need to add more lines. But the only reason it doesn't have curly braces is because once it hits the word if, okay, it checks if it's true or false. If it's false, it'll just skip the next line of code. If it's true, it'll run the next line of code. Okay. If you want it to run multiple lines and you put it in curly braces, if it evaluates to true, it runs that entire block of code. If it's false, it skips that entire block of code. So that's how, in the background, if statements work. But what we want to do here is tell it what we want to sort by. So this method is going to be called by an instance of the banana. And then it is a method where we're passing in another banana. So down here where it says this, that is implied that it is the banana that's calling this method. Okay, so if it was Chiquita calling this method, it would be Chiquita dot compare to, and then whatever object you passed in here, hopefully a banana, you could put Bob in there. It'll compare those two, and if the one being compared to, if the one that's implied returns a 1, that means it goes after the one it was compared to. If it's a negative 1, it knows it goes before. If it returns a 0, okay, I see. Okay, it wasn't returning a 0. It just returns a 0 if they're equal, okay? So why didn't they use if this is greater than, if this is less than, and then check if they were equal? Well, it's because we've included every possibility except where they're equal. So if we're looking at all the values that are, or if the value is greater than the other value, or if it's less than, that includes every possibility except 0. Or there's only one other possibility, so we can just use else. We don't have to test that. We can just return 0, because if they're equal, if it gets to this else, that means they're equal, is what I'm trying to say. Okay, so we don't want to, these don't have an ID number. We want to compare based on age, and remember, Disneyland wants to let the old people in first so that they can enjoy Disneyland. Though, if it's a situation where there's a line outside, you might want the old people to be in back, right? So they don't get trampled. Okay. You know, as you get closer to 65, you'll realize that it's not that old. So we wanted to do age. So this dot age compared to the other object passed in age and age. Okay. So we're comparing the ages between them. So if this age is higher, it goes after. So we want it to go before, so we just switch these if we wanted to sort the other way. All right, now when we call the sort, it should call compare to. So here we're printing out the list unsorted. So we'll put these. Create such a beautiful UI here. Oh yeah, this is unsorted. Okay, and then what we want to do is we want to go to our, nope, we don't want to do it in here because this is inside the loop. We want to do it outside of this loop. Otherwise, it will sort, resort the thing. Actually, I don't know if you can actually sort a list while you're doing a for each on it. In C#, I'm not sure if you can do that. Test that out and let me know. Wow, a new version of Replit is available. Fun. It's probably going to flip the UI upside down. You'll get used to this if you do want a job in technology. Things are always changing. I'll use this as my excuse as to why I seem so disorganized. While I'm teaching, the tool I use is updating. All right. So we need to do banana list dot. Oh, come on. What happened? There it is. Dot sort. Okay. See if that breaks everything. Forgot my backslash n here. But that doesn't affect the logic of it. These are the unsorted. I don't want it to say unsorted inside here. I want it to say it out here. So, whoop, let's take this. Whoops, cut that, and we'll paste it in here. I'm assuming this is why I put this here. So these are the unsorted. And then let's do one of these before and after each value. See what that looks like. So I just want this to be easy to read. Okay. These are the unsorted values. Okay, now we're going to sort. And let's also just make an extra separation here so it's easy to look at what we're supposed to be looking at. So this is sorted. And then we'll put another one here. Yeah, I didn't put this at the right level. There we go. So sorted, and we'll just make this like this, and this, and we'll make these into asterisks. Okay, so now when we print the list, it should be in order of age in reverse order, unless I totally misunderstood the 1 and -1 and which order it puts it in. In that case, we just have to switch those. So this also is on the wrong indent. There we go. But this we got to know is in here because it's only attached to this. Okay, so anyway, I'm going to do this again. And here. Okay. When you say nope, Grace, do you mean nope, you didn't see Replit until now, or you did see it before? Thank you for helping, by the way. I really appreciate this. Because I wasn't even going to go over Compareto, but now that I'm doing it, I'm like, wow. You guys probably wanted some information about that. Okay. Anyway, here we go. We don't have to change anything else. Okay, so we have Bob, Sally, coffee. It's mixed up. The middle-aged person is first. So Disney says, hey guys, we got to see your IDs because you're coming in reverse age order. And so down here we have it's in reverse order. So I'm going to give you guys this code, and then that way you can have it and you can go back through the video because I explain every piece of it. If you have questions, you can ask me. If you do it in Replit, it's really easy to send the Replit link to me to look at. If you did it in a file, you can send me that file and then I'll paste it into Replit and test it. If you want an answer on, if you ask me a question about your code and it's an error in the code, just send me the code with the question. It'll save a lot of time. In here because it's not even. There it is. No, now there's too many at the end. Okay. There, perfect. So now we have coffee, Bob, and Sally. All right, just double check here. Okay. Good, good, good. When I edit this video, I'll chop out the beginning part where I'm just staring at the screen. And then I'll post this video, the edited version, to Canvas once I edit it. And you guys can try this stuff out. And I will post that new review assignment and update those assignment dates. Again, the assignment that was already due on the 17th, I'm just going to take the due date off of that, actually, and just try to make sure you turn it in by the time we finish the Chapter 9 material. Okay. So that gives you, at least a week to do it if you still haven't done it, or to fix it. All right. I think I did everything I wanted to do in the class, so I'm going to end the stream here. And you guys know how to reach me if you're stuck on anything. All right, we should have a good class and learn some complicated stuff about C#. All right, have a good day.